In this video, we will look at an example of a problem where the question is about the value of the sample proportion instead of whether or not you would reject the null hypothesis. We'll see that when given a specific significance value, you can use the z-statistic to solve for the value needed. Let's look at an example. A botanist has produced a new variety of soy plant that is better able to withstand drought than other varieties. The botanist knows the seed germination rate for the parent plant is 75%, but doesn't know the seed germination rate for the new hybrid. They test the claim that the germination rate is different for the hybrid than the parent plant. To test this claim, 450 seeds from the hybrid plant are tested. What percentage of the hybrid plants need to germinate in order for the p-value to be less than 0.05? So in this case, let's write the null and alternative hypothesis. So the null hypothesis would be that p equals 0.75, meaning that the germination proportion is the same as the parent plant. The alternative hypothesis would be p is not equal to 0.75. The germination proportion is different from the parent plant. Since this is a two-sided test and the significance level is 0.05, that means that we need to find the test statistic that gives 0.025 probability greater than and 0.025 less than. We can find the z-score from a normal distribution table or from using the inverse normal function on Desmos. So this would be negative 1.96. And since it is a two-valued test, we have both the negative and the positive z-statistic that we need. Once we have the z-score, we can use the formula for the z-statistic in order to solve for p hat. So everything that we have is actually in this. The z is plus or minus 1.96. The p is 0.75. 1 minus p is 0.25, and n equals 450. So when you do the formula, you won't do all of the math, but the p hat is what you're solving for. And you have to do it for both the positive and the negative, right? And when you solve this all out on your calculator, p hat is either 0.71 or 0.79. So the proportion that is needed to reject the null hypothesis has to be greater than 79% or less than 71%.